I made two mistakes. First off, I mean, actually one of them is mistake. The other one is natural. So when you have quizzes, it shows past you and there is no other way. So because we are doing during the class time is a paper pencil one, I have to put the due date for that because it shows which day you have to be ready for the test. And then since it's just after grading, I can input the grades. So it doesn't show any submission for you guys. So then it shows past you. So be patient for that one, okay? So for me, it takes 1 weekend to get everything graded. So if I have it any Monday, Wednesday, test or quizzes, weekend is the only free time that I can grade it. So then only 1 weekend always, then it will be updated. The other one is about the group submission. It seems I made that's the mistake. I'm so sorry about that. It seems when I choose the groups, I made to be the group submission, but I forgot to choose the groups. So I didn't know the group submission by itself is not enough, so I have to choose the groups. So it seems whichever, so then I have to fix this one. Whoever is submitting is unfortunately is individually for now. Then I have to just, again, another weekend, it takes me time to just check who was submitting, who was getting graded or not, okay? So it seems I made a mistake, so then I don't see who is in which group. So I have to go back to my Excel sheet, check, for example, this person is submitting for 5 people. So put the grade for other 5 people too. So that's just something I fix it for the rest of semester. Only for number 1, I made a mistake and I couldn't change it anymore. That's it. And I have had a question about resources, more resources to practice. Unfortunately, different campuses are doing differently for this course. So this is really weird course. So when you go calculus classes, it's the same for all other campuses all around the world. Calculus 1 to 3 is the same for everywhere, but not 270A to 270B. They are doing differently from one campus to the other campus. So that's why the videos are different. So I have had one experience for MIT Open courses. So, but still, those courses, just some topics are useful for you. Like you can just choose it. I will put the link for you, but not the entire course. Only the one that shows logic, only the one that shows set theory. So those are that just I can recommend to watch. Otherwise, it gets for sure to more advanced that is not in your level, okay? So this is one thing. The other resource that's maybe I can say it's the best match for us in this campus is one, it's a publisher, they call it ZyBook, Z-Y book. And for that one, you have to pay. So if you give me another weekend, then I can set it. It's just really everything. I have to make you to be my student. Then I have to attach the work to your class. And then you can go and just get the registration like any other online homework. But then you have to, I think it's 70 or 60 something that you have to pay for that. That's better option. But if you're okay with paying that, it's better option because it matches with us. So it's exactly the same order.
I have a page where you guys can download the books of the plot for free. And if you guys are interested, I'll link it up. Put it on the order.
Which book? The ZyBook?
Right, yeah, for our class. Not the ZyBook?
ZyBook, yeah.
Oh, wrong.
Which one?
It's for our math class, like the actual book for our class of math.
But we have it, that one. No, we don't. You know, for the book, we do have it here. I mean, we don't have any problem with the book. Somebody was looking for more resources, not that one. So for our individual, so this is, if you go to the, where is modules? If you go to the modules and you go to the course resources, so our book is free. So it's available here. The textbook is free for us. It's available here. You can just download it here. You can keep it always here. And it's being just really attached for was it 3 different books for us, only for Calculus Fullerton, and it's free. And it is free. We don't have any problem. So for extra resource. So if you need extra resource, give me another time. I don't know who was looking, but it was a few of you. And then again, because the course material is kind of like weird, it's going to be one to the other, just different. So it's not like calculus, they are all connected. You just have to know the limit and then you go to the derivative and then you go to the integration. It's not like that. Logic is by itself, then set theory is by itself, then proof is by itself. So, and again, different campuses doing differently. So I have one book that is called the Zybook. I mean, one resource that's called Zybook, which is attached to us. And I was using that for 2 semesters. Then I stopped using because I prefer the paper pencil. So, but I can set it for you. We can set it for you. That would be another resource, MIT one, and this book is another one. This book doesn't have video. I don't think it has video, but it has more examples. If anyone else has any idea about these resources, that I don't recommend anything on YouTube. I do not. It's just really weird. They are really wrong most of the time. So I do not, I mean, sometimes even advanced. We don't need that much because this could be more advanced for my just maybe math measures in master to be logic. Okay. This is what I have had to share with you, and I'm here. Okay, so this is the last thing that we have had in last class. We were trying to add some examples to clear this negation of quantifiers. The negation of quantifiers, also called De Morgan's. Also, these are called De Morgan's. So negation of universal is existential. Negation of existential is universal. So I was going to add some examples. We haven't had time in the last class. Anyone has any question about quantifiers? We have 2 types of quantifiers. Universal means for all, for every, and it will be true if it's really true for all of the possible elements. And it will be false if you find one only counterexample. And then you have existential, which will be true only if you have one example. Then this is the negation of the universal is existential, negation of existential is universal. Okay, so that's my first example to practice this negation. Write this statement by symbols and write the negation. This is some birds cannot fly. Okay, I'm going to have my propositional statement. It says P of X is X. P of X is X flies. So, how do you write this statement? How do you write this statement? That's a very good question, yes. Some birds cannot fly. So, how do I write it? I just want to write it by symbols. Go ahead if you're ready. Whoever is ready, go ahead. Negation of P of X. But which quantifier I must use? Which quantifier? Is it universal or existential? Existential. There exists one X. There exists one X which X cannot fly. There exists one X which X cannot fly, okay? So can you negate this statement? Can you negate this statement? So this is part A, find the symbols. This is, let's say, part B. I mean, before writing the statement in the symbols, what would be the negation of this Some birds cannot fly, negate. Opposite. No idea? Yeah, that's true. That makes it really easier. If you make it by these quantifiers, it makes it really easier to write. So when you have negation of existential will be universal, then you have negation, Negation of P of X, which is P of X. So tell me by words, what does it mean?
All birds can fly.
All birds can fly, right? So you can say all birds, every bird can fly. Okay, that's a negation of the other statement. One more time. Question for this one? One more time. Write the same thing. Okay, so write this statement. By the correct symbols that we learned in last class and negate it. And again, it's word. It says every rock fan loves you too. Every rock fan loves you too. What's my P of X? What is my P of X? X loves you too. That's true. X loves you too. Okay. And then this statement. For all x's, P of X, right? For all x's, P of X. For all x's, P of X. Agree with this one? Negate it, please. Negate this statement. If you like the bar notation for negation, it's fine. Okay, you can use either one. Okay, give me by words what it says. Some rock fan, yeah, don't like this, that thing, or you can say, you can read exactly what you have here. You can say there exists a rock fan who doesn't like you too, huh? We have a discussion last class about there exists a, so why you say one? I can say better word for that is at least, but it's not wrong if I don't write at least. It's fine, okay? Because it's existential. Existential, it will be true if you have only only one sample, only one example that works. So if one of them works, that would be enough for existential to be true, okay? But if you want to like just match it with your grammar, you can say at least one rock fan who, is it wrong if I say some rock fans don't like the U2? That still is the same, okay? This is one. Another example. There exists one x in real number such that x squared plus 1 equals 2/5. Is it true? Is this true? give me my x, right? So if you say the existential is true, you have to have at least one x. Give me my x that makes this one true. 2 makes it true, right? x2, then you have 2 divided by 2 squared plus 1 equals 2/5. So as soon as I have only one sample, one example that works, the existential is true, right? Make sense? Okay, I have just one more. Is it true if I write it like this? Is this true? Because? Yeah, so you can't say it's not because that's a universal. You have to bring counterexample. Give me one counterexample, which is there are infinite many. You can bring one, right? So x equals, for example, whichever, right? So -1, then you have -1 divided by -1 to the power of second, which is not the same as 2/5. So if your universal is false, so you have to bring always counterexample. And if it is true, the existential is true, you need to bring one example that works. Any question? Do you have any comment, question, any concern about this type? Do you need more examples? Do you need more examples? That makes sense? Universal, existential, how to say is false, how to say is true. You're fine? Okay, so then I have your chapter 4, which is set theory. According to the schedule, we jump to the chapter 4, back to the chapter 3. Okay. This is an example. We are trying to start what is the subset and then power sets. But the thing is, we already know what's the sets, right? So we know what's the subset. We know what's the union. So all of those concepts as we've seen in algebra classes, it's fine. I mean, we are not talking about those type of definition for this sets theory, okay? We are talking about the logic. So we want to get a connection between what we are going to learn right now in chapter 4, what we have learned in chapter 2, right? So every single statement here has a logic equivalency. So it means it could be implication, it could be disjunction, it could be conjunction, and then you can just say whether it's true or false, okay? So we are talking about set theory, that part which is connected to the logic, not the part that we have learned in algebra classes, okay? But sometimes I need to review for you guys to remember what you know about the sets and subsets. So for the first one, there is just always in this section something that's include every single, and that's something that include every single set is called universal. So you have universe. So you have universal set. If you're talking about the geometry, just universal set could be the set of all figures. If you are talking about the number, the universal could be just the set of all possible numbers, including rational, irrational, complex. So it depends on which topic we have. If it's like just set of cars, so then the universal is the set of all brands, okay? So that is always notation. The notation is always by universal. This is an example, like saying the universal is defined the set of all possible figures. And then your capital S stands for squares. That's just an example, okay? Not necessarily always. P stands for parallelograms, R stands for the rhombus, and then L stands for rectangles, C stands for the circles. So use this Venn diagram. What's the Venn diagram? The one that we use the rectangle circles to show the sets. Okay, use the Venn diagram to see what is the relation between these sets. So this is my universal. This is my universal, the big one, the set of all figures. I don't know which one is subset, right? So let's see. Parallelogram. What else I can have? Can I have rectangles is subset of those? Rectangle, I'm going to make this one bigger. Rectangles is subset of parallelograms, right?
Yes.
And then also rhombus is subset of parallelograms. What's this intersection? Which shape is rhombus? Squares, huh? So the intersections are squares. So the shape that is rhombus and rectangle is the set of squares. Do you agree by now? Do you have, does it make sense, these relations? Okay, so I have only circles left, huh? The circles is somewhere here. So if you want to write it by notations, you can just say parallelograms is subset of that universe. You can say a rhombus is subset of parallelogram. You can say squares is subset of rhombus, right? You can say rectangles is subset of parallelogram. Circles is subset of universe. Am I right? Those are the possible. There are many others, right? Can I? Did I miss anyone? Did I miss any of these relations? Actually, the question didn't ask me to write all this relation. I'm just practicing. It asks you to just write the Venn diagram, which you have done right. I wrote LP, I wrote RP. SL you didn't write, right? This is S and L. Square subset of rectangles. I think we wrote everything, right? So that's an example. And then again, what do you call subset? So if you have subset A is subset of B, so means whichever element you choose from A, whichever element you choose from the A is also in the B. So that's the definition. And then if you go backward or it's just looking B is called super set of A. B is superset of A is subset of B in this notation. One more time, this is natural numbers. This is integers. And these are real numbers, right? So this is the notations that we know. How they are related again? Which one is the smallest? So this is the smallest. Then after that, what's after? Set of integers. And what's after? Set of real numbers, right? Okay. So let's see, are they true or false? Can I have negative, the set of -1, 2, the set of -1, 2 is not subset of natural number. Is it true or false? True or false? Is it?
True. Natural numbers are not negative.
Natural numbers are only the positive numbers, so this not means that's true statement, okay? Here, -1 and 2 is subset of integers. Is it true?
Yes.
Okay, so then you have and statement. That means true is true, okay? Move on, the next one, it says the set of all integers. So the set of all integers, which is what? X squared is less than or equals 1. So again, this is the set of all integers, which x to the power of second is less than or equals 1. That's how you read it, right? So what are those integers? What are the integers which x to the power of second is less than or equals 1?
Zero.
Integers could be negative 1, 2, right? So could be negative 1, 2. Is it subset of real numbers? Is this subset of real numbers? Yes, right? And the last one is obviously 2, right? So 1, 2, 3 is subset of n. Just think about why this is true. That's interesting. You see, when you say 1, 2, 3 is subset of n, which means you are agreed that 1 is one element of the natural number and 2 is one element of the natural number and 3 is one element of the natural number. So basically you have conjunction. This is a true statement. So that's why the whole statement is true. So if one of them is false because it's and, if one of this statement is false because it's and the statement, so then the whole thing is going to be false. So when you're writing 1 and 2 and 3 is subset of natural number, means you're just having conjunction. Each element is in n, so all of them are true. So then the whole thing is true. Make sense? And just a quick reminder that if you're having A is not a subset of B, if A is not a subset of B, not necessarily B is subset of A, right? So it's not always true if you just say A is not a subset of B, so B has to be subset of A. That is not true, okay? Don't ever assume that's true. So like saying your A and B could be like this. A is not a subset of B, B also is not subset of A. That's possible. A and B could be like this. A is not subset of B, B is not subset of A, okay? So when you're having A is not subset of B, not necessarily B is subset of A because they could be really completely disjoint. Question? For the set theory that we want to cover, as I said, is just the logic or the connection to the logic. So as we see, one equivalent definition. So if you have subset is the same as for whatever X you choose from the universe, if X is in the A, that's implication, then X is in the B, okay? So corresponding to the subset, you have implication statement. You have implication statement. Like, for example, if for some reason this is false, if for some reason the first, which is the P statement, is false, the whole statement is going to be true. No, it's not working. Any idea? Freeze. It is freezed. What should I do? Turn it off, huh? It's not moving. And it's not working too.
Does it have